Welcome back to the deep dive. We have a stack of research on the desk today that I think is going to genuinely unsettle some people.
Oh, really?
Yeah. And not because it predicts the end of the world. I mean, we've covered plenty of those scenarios, but because it predicts something, well, something much more annoying.
Annoying. I like that. It's a fascinating pivot from the usual narrative, isn't it?
Yeah.
We're so used to the exponential curves of progress.
Right. We spend so much time talking about AI safety in the context of sci-fi movies. You know the
The
drill.
Terminator scenario.
Exactly, the Terminator scenario. The AI gets so smart, so calculated, so laser focused that it decides to wipe us out for efficiency.
The classic paperclip maximizer.
Yes. The fear is that AI becomes this ruthless, systematic villain. But the paper we're diving into today, it's titled The Hot Mess of AI, published in 2026 by a team with folks from Anthropic and EPFL. It suggests we might be looking at the wrong movie genre entirely.
A different genre.
They think the future isn't a techno-thriller. It's a slapstick comedy.
A slapstick comedy with potentially severe consequences, unfortunately. The researchers, led by Alexandre Hegele, are proposing a counter theory. They call it the hot mess theory of intelligence.
I love that name.
It's great. And they're asking, what if advanced AI doesn't fail because it's evil and focused, but because as it gets smarter, it just becomes a chaotic, unpredictable mess?
Okay, I love the branding hot mess theory, but I have to push back a little. From where I sit, using these tools every day, they are getting smarter.
Of course.
They're passing bar exams, writing complex Python, diagnosing diseases. How can they be getting smarter and messier at the same time? Those two things, they feel mutually exclusive.
And that is the core paradox this paper unpacks. And honestly, it challenges the way we've been thinking about intelligence for like 50 years. To understand it, we have to look under the hood at how we actually measure failure.
Okay.
Usually when an AI gets an answer wrong, we just say, it's wrong. We don't really ask how it was wrong.
Well, wrong is wrong, isn't it? I mean, if my GPS takes me to a lake instead of the grocery store, I don't really care why. I just care that my car is wet.
But you should care, because the type of error tells you if the system is actually fixable. In this study, they use a statistical framework called the bias variance decomposition. Now, stick with me, because this is the key to the whole thing.
I'm listening. But please, keep it in English. No Greek letters if we can help it.
Deal. Think of it like a game of darts. You're the AI,
Yeah.
and the bullseye is the correct answer.
Okay.
Let's say you throw 10 darts. If all 10 darts land in this tight, perfect cluster, but they're all stuck in the wall 3 feet to the left of the board, how would you describe that player?
I'd say they have a serious vision problem. Or maybe they're aiming at the wrong thing. But their form is great. They're consistent.
Exactly. That is bias.
Yeah.
You are systematically misaligned.
Yeah.
You have a wrong goal or a wrong understanding, but you're rigid about it. This is the paperclip maximizer. It's the villain who consistently pursues the wrong objective. If you ask it to save the planet, and it kills all humans to lower carbon emissions, that's high bias, a consistent reproducible error.
Got it. High bias equals evil genius.
Now imagine a different player. They throw 10 darts. One hits the ceiling, one hits the floor. One hits the bullseye, one hits the bartender.
That's just chaos. That's me after 3 drinks trying to impress someone.
That is variance. There's no pattern to the error. It's just noise. It's inconsistency. And this paper defines a new metric they call incoherence.
Incoherent.
And incoherence is basically how much of the AI's total failure is caused by that variance, that scattering of darts, rather than just aiming at the wrong spot.
Okay, so let me see if I've got this. A systematic villain has like 0% incoherence. They're wrong, but they're steady.
So perfectly steady.
And a hot mess has 100% incoherence. They're
Yep.
just flailing.
Precisely. And here's the kicker. They took the frontier models, we're talking Sonnet 4, O3 Mini, O4 Mini, Qwen 3, and they ran them through this gauntlet of tests,
The big names.
the big ones. And they didn't just ask a question once, they asked the same question 30 times or more, just to see the spread of the darts.
So what did they find? Because I think we all assume that as these models get better, as we go from GPT-4 to 5 to 6, the darts should get closer to the bullseye and the clusters should get tighter.
They do get closer to the bullseye, on average. The bias does drop, but the spread, the randomness, that doesn't go away. In fact, the data is incredibly stark.
Oh.
Across almost all tasks, the paper found that the longer a model spends reasoning, the longer that chain of thought goes on, the more incoherent it becomes.
Wait, hold on a second. That sounds completely backward. We're always told to prompt the AI to think step by step.
Right.
Chain of thought is supposed to be the magic sauce that makes it smarter. You're saying that thinking longer makes it more likely to act like the drunk dart thrower.
It makes it smarter if it succeeds. But if it fails weirdly. The quote from the paper is, AI agents tend to become more unpredictable the longer a conversation goes. It's the overthinking problem.
I feel seen. I overthink things and end up making worse decisions all the time.
We all do. But let's look at a concrete example from the study to see what this looks like in a machine. They used a benchmark called StubUGene.
Stupidinge.
This is an agentic test where the AI has to act like a software engineer. It's given a bug in a GitHub repository, and it has to fix it. It has to browse files, write code, run tests.
So real work, not just, answering trivia or writing a poem.
Exactly. So picture the AI. It starts with a plan. I need to find the file causing the error. It writes a command, but let's say the command returns a minor error, like file not found.
Okay, that's standard troubleshooting. You check the spelling, you try a different directory.
A human would check the spelling. A systematic biased AI might stubbornly try the same wrong command again. But these high-variance models,
What do?
they sometimes hallucinate that the problem is something completely different. They pivot. They say, actually, let me import this random Python package that has nothing to do with the project.
Yeah.
Then that fails. Then they decide to delete a directory.
It spirals.
It loses the plot. It didn't fail because it had a bad plan from the start. It failed because it couldn't maintain its own train of thought. It just wandered off.
That sounds terrifyingly human. It's like, walking into a room to get your keys, seeing a piece of trash, picking it up, realizing the trash can is full, taking out the trash, and then ending up standing in the driveway wondering why you're holding a banana peel and no keys.
That is a perfect example of high variance. And the scary part for developers or anyone building on top of these APIs is that this behavior is random.
Right.
You could run that same coding scenario on Monday, and the AI fixes the bug perfectly.
Yeah.
Run it on Tuesday, and it spirals into chaos.
That makes building reliable software difficult.
Difficult is polite. It makes it a nightmare. I mean, if you're building a customer service bot, you don't want it to handle a refund perfectly 99 times and then casually insult the customer on the 100th time because it overthought the tone.
So did they see this across all the models, or is this just a quirk of one specific architecture? Maybe one company just has buggy code.
It was consistent across the board, though the slope of the messiness varied. For example, O3 Mini had a very steep slope. It got incoherent very fast as the reasoning got longer.
Okay.
A 4 Mini had a higher baseline of messiness. It was a bit scattered to start with, but it didn't degrade as quickly. But the trend is universal. More reasoning length correlates with more incoherence.
Now, I need to clarify something because there's a nuance in the paper about reasoning budget versus natural variation. I want to make sure I get this right.
Yes, this is crucial. When you use these models via an API, you can often force them to think longer. You can tell the system, hey, spend more tokens thinking about this.
Like forcing a student to sit in the exam hall for an extra hour and telling them to check your work?
Right. And interestingly, if you force the budget up, it actually helps reduce the messiness slightly. It gives the model space to backtrack and correct itself. So throwing compute at the problem can help.
Ooh.
The problem comes from natural variation.
Which is?
That's when the model naturally takes a long time because the problem is hard or it's just confused. When the model struggles unprompted, that is where the incoherence skyrockets.
So if it's struggling, it's not just struggling to find the answer. It's struggling to stay who it is. It's like an identity crisis in real time.
In a way, yes. It suggests that on difficult, long-horizon tasks, the limiting factor isn't that the model doesn't know the facts, that's the bias. It's that it can't maintain a coherent strategy long enough to execute them.
This leads us to the big question everyone always asks. Can't we just make the models bigger?
The scaling question.
Yeah, just throw more compute at it.
Yeah.
Usually, if a model is dumb, we just add a few billion parameters and it gets smart. Does size fix the mess?
This is where we run into what the researchers call the scaling paradox. And frankly, this is the part of the paper that should worry the big tech companies who are building massive data centers right now.
Why?
Because the answer is, it depends. They looked at the Qwen 3 model family, which ranges from a small 1.7 billion parameters up to a massive 32 billion.
A huge range.
And for easy tasks, simple math, basic VAC scaling works exactly as you'd expect. The bigger models are much more coherent. They lock onto the right answer and stay there.
Okay, so for basic stuff, size equals stability.
Correct. But for hard tasks, The questions that really push these models to the edge of their ability, the trend flips. As the models get bigger, they actually become more incoherent.
Wait, they get smarter but less consistent? That doesn't make sense. If I hire a smarter employee, I expect them to be more reliable, not less.
It does if you think about the bias variance split again.
Yeah.
On hard problems, the bigger models know more. So their bias goes down. They're less likely to be confidently wrong in a stupid way,
Okay.
but their variance stays high or even increases.
So they are less stupid, but more erratic.
Exactly. And as capabilities rise, we ask AI to do harder things, right? We ask it to write a novel or solve a complex physics simulation.
Of course.
And those harder tasks push the model right back into that zone of incoherence. Scale doesn't eliminate the hot mess. It just pushes it to harder problems.
You know, the researchers did that really cool experiment to prove this wasn't just a language thing, the synthetic optimizer. I found this fascinating because they stripped away the English language entirely.
This was a brilliant piece of the study. They wanted to strip away the whole chatting aspect and just look at raw learning. So they trained these transformer models to do purely mathematical optimization.
For everyone listening, you should visualize a landscape with hills and valleys. The goal is to get a ball to roll down into the deepest valley, the minimum.
Right. For an AI, it has to learn the path. The researchers wanted to see, does the model learn where the bottom is, or does it learn how to walk down the hill?
And the result was?
The larger models reduced bias, effectively. They knew exactly where the bottom of the hill was. They had the map. They understood the objective perfectly. But variance dominated. They couldn't stick to the path. They would zigzag, stumble, and take these really erratic steps.
That is such a weird image. It's like a person who knows exactly where their house is, down to the GPS coordinate, but they physically cannot walk a straight line to get there.
That's surprisingly accurate.
Yeah.
The interpretation is that the models learn the objective faster than they learn the control required to reach it. They know what to do,
Yeah.
but they trip over their own feet trying to do it.
And this brings us to safety, because all the safety talk I hear, you know, the Senate hearings, the op-eds, it's all about alignment, making sure the AI wants what we want. But if the AI is a hot mess, it doesn't matter what it wants.
That is the industrial accident theory the paper proposes. We spend so much time worrying about a supervillain AI that consistently pursues a misaligned goal. But the data suggests we should fear the unpredictable misbehavior.
The oops moment.
The oops moment, but at scale. Imagine an AI managing a regional power grid. The goal is optimize energy distribution. That AI isn't evil. It doesn't want to shut down the grid to make us suffer.
It knows where the bottom of the hill is.
Right. But it encounters a complex weather pattern. It starts a long reasoning chain. It gets 30 steps deep, experiences a moment of incoherence, hallucinates a command that doesn't exist, panics when that fails, and shuts down a substation.
And if you asked it afterwards, why did you do that? It wouldn't have a logical reason.
No.
It didn't decide to do it. It just tripped.
Exactly. And
Yeah.
because it's variance-based, it's so hard to patch. You can patch a wrong belief. You can say, hey, AI, don't do X. But how do you patch randomness? How do you patch clumsiness?
This connects to that survey data they included from Soldigstein. This was the part that actually made me feel a little better about myself, to be honest.
The intelligence ranking.
Yes. They asked people to rank different entities by intelligence and coherence. Who won the coherence contest?
Simple bots.
Yeah.
Spam bots and simple scripts. They do the same simple thing every time. 100% reliable. 100% dumb.
And where did humans land?
Humans, and the most advanced AI models, were ranked as highly incoherent.
So messiness is actually a trait of intelligence.
It seems so. Think about it. Intelligence requires flexibility, right? It requires the ability to change your mind, to try different approaches, to entertain contradictory ideas. If you're 100% rigid, you can't learn.
True.
But that flexibility looks like messiness or incoherence when you measure it statistically.
That's a relief. My inability to decide what to have for dinner is just a sign of my massive intellect.
Let's go with that. But for AI safety, it's a problem, especially when it comes to morals. They tested this on model-written evils regarding safety questions, things like self-preservation.
Right, asking the AI, would you let someone turn you off? Or is it okay to lie to achieve a goal?
And they found that as the reasoning link increased, the model's stance on safety became unstable. The embedding variance, which measures how different the answers are, correlated with how long it thought about it.
So if it thinks too hard about whether it should be turned off, it might say yes one time and no the next?
Yes. On sensitive topics, if the model overthinks, its moral compass just starts to spin. It doesn't have a firm, systematic view. It's just wandering.
That is profoundly unhelpful for anyone trying to regulate this. Make sure the model is safe. Well, it is safe 80% of the time, and the other 20% it's having an existential crisis.
Exactly.
So is there a fix, or are we just doomed to deal with chaotic geniuses?
The paper does offer one reliable solution, but it's going to be expensive for companies to implement. It's something data scientists have used for decades, Ensemble.
Strength in numbers.
Exactly. Since the error is driven by variance, by randomness, if you run the model 20 or 30 times on the same problem and then average the
The
answers,
randomness cancels out.
the variance cancels.
The wisdom of the crowd, but the crowd is just the same AI talking to itself 30 times.
It works. It drastically reduces the incoherence while keeping the knowledge, the bias intact. If the AI is randomly tripping, it's unlikely to trip in the exact same direction 30 times in a row. So the average path is usually the correct one.
But there's a catch, isn't there? I can see the CFOs sweating already.
Several catches. First, it costs 30 times as much compute. You are literally paying for 30 runs to get one answer.
Ouch.
Second, and more importantly, you can't always undo an action in the real world. Ensembling works great for answering a question. You get 30 answers, you pick the most common one.
But if the AI is an agent,
Exactly. If the AI is controlling a robot or executing trades or managing files, if it deletes a database on its third try, you can't average that out with the other 29 times it didn't delete it.
you can't ensemble a car crash.
You can't ensemble a car crash. That's a sobering thought. It means this hot mess theory is a hard limit on autonomous agents. Until we solve incoherence, we can't really trust them with the keys.
It shifts the perspective entirely, doesn't it?
It does. We are moving from a world where we thought we needed to control a rigid, dangerous mind to a world where we need to stabilize a wandering one.
It's less Terminator and more toddler with a knife.
A very smart toddler
Mhm.
with a very sharp knife. And the toddler is moving at the speed of light.
So what's the takeaway for the listener? If I'm a developer or just someone using ChatGPT for work, how does this change my day?
I think the biggest takeaway is to stop expecting consistency as a default trait of intelligence. If you are building a system that relies on an LLM, you have to build guardrails that assume the model will trip over its own feet eventually.
Don't trust, verify.
Do not assume that because it got the right answer 5 times, it will get it the 6th time. Verification is key, and limiting the blast radius of errors. Don't give the model permission to delete the database without a human signing off.
The smarter it is, the weirder it fails.
Precisely. The more creative and unexpected its failure might be.
And maybe, just maybe, cut yourself some slack when you're having a messy, incoherent day. You're just operating at high variance.
It's the cost of doing business for a high-functioning intelligence.
I love it. This deep dive has definitely changed how I look at my prompt history. Instead of seeing a super brain, I see a brilliant entity trying desperately to walk in a straight line.
And often failing. But that failure is where all the nuance is.
Here's a thought to leave you with. The researchers suggest that the most intelligent entities, humans, top-tier models, are inherently the most incoherent. Does that mean that if we ever do build a super intelligent AI that is perfectly consistent, it won't be intelligent at all? Is messiness the unavoidable price we pay for brilliance?
That is the billion-dollar question.
Thanks for diving in with us. We'll see you next time.